If you look into Kubernetes, most of the objects in Kubernetes has the option to add labels. You can add any number of labels in these objects, and there are selectors as well. These selectors, what it does is it will group objects as per the labels provided. Here we are going to look into some of the scenarios where we can use labels effectively. Here in this example, you can see that there are three ports. Port 1 is having the life cycle as end of life, version as V1 and application as test. Port 2 is having the life cycle as updated, version as V2 and app is test. Port 3 life cycle latest, version V2 and application test. So we know that there are different versions of the same application is available here, and we can use labeling on selectors to group these or categorize these applications. Let us see which are ways we can categorize these applications. Here it says that list all the ports whose life cycle is end of life. We know that port 1 is end of life, and that port will be listed. Next one is we can say that which all applications are in version 2 or which application is not in version 1. Here port 2 and port 3 will be listed. Another listing is which ports are available in application test. Or we can look into some other way as well. We can say list all the applications with version 1 and 2. Here you can see that kubectl get ports -l version in v1 v2. That means whichever ports are there with version v1 or v2, list it out. This way you can categorize the applications. Suppose we want to list all the end of life applications to see how many need to be upgraded. That easily we can do with labels and selectors. Next one is we can use labels for node selection. There will be some application which need high capacity machines, or some other application need only regular machines. In that case, we can label our machines according to its capacity. Here worker node 1 is labeled as node type, the regular. Then worker node 2 is labeled as node type high mem. So here two manifest files are mentioned. Here first one is saying that it need only the node type regular. The second one says node type high mem. If we are not mentioning this selector, any of these ports will get deployed into high mem, and whichever port need actual high mem machines may not be deployed into high mem capacity machine. So to avoid that one, we can use node selector, and we can label the node appropriately, and we can use node selector in the deployment. You can see that the first one is deployed into the worker node 1, second is deployed into worker node 2. Mostly when we deploy our applications, there are multiple deployment strategies. One of it is the blue-green deployment. If you are doing blue-green deployment, that means we'll have blue deployment that is already serving customers, and the green deployment is the latest updated version of the application. Once the green deployment is tested well, we'll just swap the connection to green. That way there will not be any downtime for the customer, and the customer will not feel any latency in the application. In our company, if we are not using any service mesh, we can use the same approach for doing a canary deployment as well. Canary deployment is nothing but we'll redirect some of the requests to the new applications. That way, some customers will get the experience of the new application, and if there are any issues, they will report us and we can fix it. So with a small trick, we can do that as well with labels. Here you can see that the service is written with the app label as app is equal to test. We can deploy green also with app is equal to test with a smaller number of ports. Here we are deploying only one port. This way, maybe 3 requests will be going to old application, but one request will be going to new application. Once the canary testing is done, we can replace old application with the new application. In the remaining section, we can see a small demo of how this label and selector works.